dear viewers, I am Rushan Menon from class 7th E. Srimati Sunitidevi Singhania School is proud to present before you Prajwalan, Ignite the Fire of Learning. On behalf of the students of grade 7th, I would like to extend a very warm welcome to our director madam, Mrs. Revati Srinivasan, our school head, Mrs. Lakshmi Madhusudan, our mentor, Mrs. Gladys Cabral, coordinators, teachers, and our dear parents. Max Planck has beautifully quoted, "When you change the way you look at things, the things you look at change." As a kid, I looked at an apple with joy. The sight of an apple reminded me of the sweet taste and the bright color. As I grew and learned science and started relating apple to gravity, aspects of motion, reflection of light. Did you know an apple can light an LED bulb? I was overjoyed with my findings. How everything around me was related and scientifically explained and made much more sense right now. Physics, the study of natural science that deals with things like matter, force, energy, motion, etc., holds a special place in my heart. Physics and its role in life is endless. Today, in Prajwalan, Ignite the Fire of Learning, we shall see experiments of physics associated with our life.
This is how an hologram works. There is a source of light. Most of the times it's a laser. This laser is shined over a beam splitter. This beam splitter splits the beam into two beams an object beam and a reference beam. The object beam is shined over the object we are making a hologram of. In this case, we have a vase. The object beam and the reference beam both meet up at the photographic plate. On the photographic plate, these both beams are recorded and create an interference pattern which is formed by the two beams of light. This then creates a 3D hologram of the object.
Which helps understand if the proportional amount of a particular color of light in a mixture of colors affects the color of the light obtained. For this, we will need two pieces of green gradient paper and one piece of each blue, yellow and red gradient paper. We will also need a small torch and a plain white screen on which you can observe the color of the light obtained. First, we will hold the blue and one piece of green gradient paper in front of the light pointed towards the screen. We see that a cyan colored light is obtained on the screen. Now we hold the other piece of green gradient paper here too. We see that a slightly greenish cyan colored light is obtained on the screen. Now let us do the same thing with red and yellow gradient paper. We see that an orange colored light is obtained on the screen. We must note that yellow light is a mixture of red and green light. This shows us that the proportional amount of a particular color of light affects the color of the light obtained. Now, we also understand how filters work. We see that the intensity of the light from the torch and the light falling on the screen is different. The intensity of the light from the torch is greater. The filters, therefore, absorb the color from light, and the colors which can be seen on the screen are the only ones not absorbed from the light. This makes us understand that the colors of white light can form any color in the world, only that they have to be mixed in the accurate proportion. Now, is it very tough to make filters? Well, no, it isn't. If you hold the red and yellow gradient paper in the room light against some object, you will see it appears to be orangish in color. We can see that everything appears to be orangish in color. Let us try the same thing with another combination of red and blue. We can see that magenta colored light is obtained. Everything appears to be magenta in color. Now, let us try to pass light through this and see if the color of the filter and the color of the light obtained on the screen are always same. That magenta colored light is obtained on the screen. This shows us that the color of the filter and the color of light obtained if we pass white light through it are always.
Hello everyone, today I will show an experiment on refraction of light. As we know that light travels in a straight line and in the same medium. So when it travels from one medium to another, it bends, which is known as refraction. In this experiment, I will show you the refraction of light using a pencil. As you can see, the pencil appears bent. This is because when light travels from air to the glass, its speed changes. As glass is denser than air, the speed of light decreases. That's why the pencil appears bent.
Good morning everybody. My name is teacher. This is Sonam Pandey and my head ma'am. Mrs. Lakshmi Madhusudan, for providing me with all the facilities required for the completion of this project. My topic for today is solar energy. As we know, the law of conservation of energy, which states that energy cannot be destroyed nor be created. It can only be changed from one form to another. Hence, to prove this, I have got a working model of a solar panel which converts solar energy into electrical energy. The aim of this project is to find out and replicate the working of a solar panel. The material required for the completion of this project are a light source. I have used a bulb here, a solar panel, two connecting wires, a fan and a motor. Let me explain you the process of this experiment. When I switch this bulb on, it will give out heat and light to the solar panel, which will convert it into electricity. The electricity will be transferred to the motor by the help of these connecting wires. When the motor turns on, it will make the fan work. Let me demonstrate this. As you can see, the fan has started working. Conclusion: solar energy is a clean, pollution-free and a renewable source of energy. It's good for ourselves and
Hello everyone, I am Prajwalan Yadav studying in Standard 7E and today I am going to conduct an experiment with lemon and water. The materials required for the experiment are 2 lemons, 2 glasses of water, salt and a spoon. First, we have to put a lemon in the first glass of water. We can see that the lemon settles at the bottom. Then we have to mix salt in the second glass of water. We have to stir it well. Then we have to put the second lemon in the salt solution. We can see that the lemon is floating at the top. Observation: we observe that in the first glass of water, the lemon settles down because the density of the lemon is higher than the water. In the salt solution, the lemon floats at the top because the density of the salt solution is higher than the lemon. Conclusion: density is the mass of a volume of a material substance. The formula of density is equals to mass upon volume.
Hello everyone, my name is Sunitidevi from 7th E. Today I am going to show you a conduction detector which I have made from some material. Our aim is to find out materials which conduct electricity such as copper, steel, iron, etc. For examples, we will be using a steel spoon and a plastic spoon. When I put my steel spoon, the light starts glowing, which means that steel is a good conductor of electricity. Now, when I put my plastic spoon, it does not glow, which means plastic is not a good conductor of electricity. This is my conduction detector. I have used this battery for electricity. So when the power is switched on, the battery produces the electricity to all the wires. From here, the electricity is passed into this pin, and this pin is attached to this antenna, which gives electricity to this also. Then from here the electricity is passed into this pin, and this pin gives the electricity to the pin of the bulb. and this is how this goes to the bulb, and the bulb gives the electricity to this pin which is attached to the right antenna. And as there is a gap between these two antennas, the circuit is not completed. When I put the copper wire or a stick, the bulb starts glowing. This shows that copper is a good conductor of electricity, and that is why it is completing the circuit. My observations are that when I kept the copper wire on the antennas, the bulb started glowing because it completed the circuit, which means that copper is a good conductor of electricity. But when I keep a wooden substance on the antennas, the bulb does not glow, as it does not complete the circuit, as it is not a good conductor of electricity. My findings are that copper, steel, aluminium, iron are good conductors of electricity, and wood, plastic, silicon, rubber are bad conductors of electricity. My conclusion is that we use many substances which are good and bad of conductors of electricity. For example, a wire. A wire has a copper wire inside and also has a rubber coating from outside. The rubber coating prevents us from getting an electrical shock, as it is an insulator of electricity. But the copper wire inside does its work of conduction of electricity. The limitations are that the conductor cannot be kept near water, as it can produce an electrical shock. Heavy substance cannot be kept on the conductor, as it can dismantle it. Long substances should be used to see if it is a good conductor or a bad conductor of electricity, so that the substance touches both the antennas of the conductor.
Good day everyone, my name is Srinam from 7th A, and today I am going to do an art integrated activity on static electricity. For this activity we need a balloon, pieces of aluminium foil and a woolen cloth. Okay, let's begin the activity. For this we need to rub the woolen cloth against the balloon, which forms static electricity. This causes the electrons to move from the woolen cloth to the balloon. So if we bring the balloon near the pieces of aluminium foil, the aluminium foil gets attracted to the surface of the balloon. This is because of the opposite charges getting attracted to each other.
The presenter is Shriya Rajan from 7C. What are we going to learn about today? We are going to be learning about the Mpemba effect. But what does that mean? I'll get there in a minute. Aim is to see if hot water or cold water freezes first, and to learn about the Mpemba effect. The materials needed are 1 cup of cold water, 100 ml in volume, 1 cup of hot water, 100 ml in volume, 1 stopwatch, and a pen and paper. Observations. Now before we get on to the observation, I would like to define the Mpemba effect in a few words. The Mpemba effect is a name given to the observation that a liquid which is initially hot can freeze faster than the same liquid which becomes cold under otherwise similar conditions. But didn't we just see the exact opposite of what was supposed to happen? According to my observation, the cold water froze faster than the hot water. But why? Does that mean this famous phenomenon is false, or does it have more to it? Let's find out. Findings. So as we saw in the video that the cold water froze faster than the hot water. But this phenomena has a very complicated history behind it. So Erasto Mpemba, who was a Tanzanian student, found this out at school when he was making ice cream with his friends with boiling milk and sugar. He was supposed to wait for the milk to cool down, but in a rush he kept this hot milk in the refrigerator and removed it way sooner than the other ice creams that were kept to cool. He found this had frozen into ice cream first. This is also said by Aristotle, the hot begets the cold quicker. In 2013, scientists at Nanyang University, Singapore, argue that covalent bonds in hot water are contracted, which means shortened, and the hydrogen bonds are stretched longer, and that the structure allows the water to release energy faster, thereby reaching the freezing state quicker. It is possible that it works because of supercooling, that the water that is in negative 10 degrees Celsius takes more time to become ice than the one at 100 degrees Celsius. Limitations. Getting results and knowing why or how it happened remains a mystery. Temperatures have to be constantly monitored with temperature probes to make this happen. Conclusion. This effect is very real, but it works in extremely specific situations due to reasons like evaporation, supercooling, convection, etc. The Mpemba effect is very specific in terms of temperature.
I am Anusha Nayak from class 7E and I am going to perform an experiment on air pressure vacuum experiment. The materials which we require are a plate, a tissue paper, an empty glass, a glass with colored water, a candle and some matchsticks. First, we need to take a tissue paper and place it on the plate. And now we can pour the colored water into the plate. Now place the lit candle in the middle of the plate. Now we can place the glass upside down over the burning flame. Fire uses all the oxygen available in the glass, and when it consumes all the available oxygen, the flame extinguishes. Now the water from the wet napkin gets sucked in the glass, causing it to create a suction, and the glass gets stuck to the plate. The air pressure outside is more and there is a vacuum in the glass. So as you can see, the glass can also lift the plate. Now when I add weight onto the plate, the glass is still able to handle it.
Good morning teachers and all my dear friends. Today I, Neil Devan, am going to do a physics experiment based on air pressure. In this experiment, I will show that air occupies space and exerts pressure. Insert the balloon inside the bottle like this. Then cover the mouth of the bottle like this. Now try blowing air in this balloon. As you can see, the balloon is not expanding because there is air inside the bottle which is exerting pressure on the balloon and not letting it expand. Now, with the help of the sharp object, I am going to pierce a hole in this plastic bottle. This is the hole which I have pierced. Now, I will try blowing air in this balloon again.
Our topic today is tornado in a bottle. Our aim is to understand why a tornado appears in a water bottle. The materials required are an empty glass bottle with a lid, food color, glitter, funnel and water. We have to use the funnel to put the food color and glitter in an empty bottle. Next, we have to fill the bottle about 3/4 full of water. Then we have to put the lid back. Then we have to turn the bottle upside down and quickly move the bottle in circular motion for 10 to 15 seconds. Finally, we have to set the bottle down and observe the tornado that has formed. We observe that a tornado in a bottle.
Hello everybody, I'm Dash Pandit from class 7D and today I'm going to be performing an experiment based on air pressure. So for this experiment what we need is a ceramic plate, candle, food coloring so that we can see the water easily, matchstick for a lighter and a glass. So first we light the candle, then we take the glass, invert it and keep it on top of the candle. So as you can see, the candle blows out and the water starts to gush into the glass. This is because the air inside the glass warms up and its air pressure becomes lower than the air pressure outside the glass. So the air outside the glass forces the water on the plate into the glass. The water stops rising when the air pressure inside the glass and outside the glass equalizes.
Hello all, I am Dev Pandit from class 7E and today I am going to show you how to suspend a filled water bottle with toothpicks. Materials required are 3 toothpicks and a filled water bottle along with a thread attached to it. Procedure: we first take the water bottle and find the topmost part. Then we take another toothpick and we attach it to the top, like so. Then we take another toothpick and hang it over here. Then we place another toothpick to balance the whole structure. So over here now, as we can see, this bottle is coming down due to gravity and the force is getting cancelled with this toothpick and hence the bottle is suspended in the air now and the equilibrium is maintained.
This is Pranshu Saha from 7th A and today I am presenting you today a milk fireworks. As you all know, in Diwali and New Year we enlight many fireworks which could lead to air pollution and creates global warming, and this is harmful for human beings. So to make it, I have made an experiment which is related to surface tension. As you can see, I have a plate of milk. I have added red food coloring to it. Now I have some more food coloring. I will add it to it. I have a green food coloring. I will add some green food coloring to it. As you can see, there is red, orange, and I will add one more food coloring. And it is green. So now you can see I have food colorings like red, orange and green. Now to make it, I am going to add a earbud with it and I have a dishwasher. So I will have the dishwasher, put it in the earbud. As you can see, I have an earbud with the detergent. And now I am going to put on it and I will now put it inside. So you can see, as if I add like more of this, many colors are spreading like fireworks. As you can see, many fireworks are coming. And can you see some bubbles coming in, out? These are also a significant sign of surface tension. Hope you like this activity.
Radioscope. A kaleidoscope is an optical instrument with two or more reflecting surfaces tilted to each other at an angle, so that one or more parts of objects on one end of the mirrors are seen as regular symmetrical pattern when viewed from the other end due to repeated reflection. Today, we are going to make a kaleidoscope and observe its reflections and designs. So let's start with it. So first I am going to introduce some of the materials which we need. Materials: 3 mirror strips to make a prism, beads in a box, sticks in a box for making design or patterns, one hollow tube which is 1/4 part cut such that it becomes a joint, tube lid tipped stick with a butter paper, 2 thermocol circles size and shape of the prism, 1 thermocol circle with a small hole. Hello, my name is Shaunak and today I am going to explain you to have made the process of how to make a kaleidoscope. So for materials, I have taken 1 hollow tube such that it's a joint, a 1/4 joint, a mirror bands, 3 mirror bands to make a prism, some beads, hollow loop tape with a butter paper, thermocol circle with a small hole, and 2 thermocol circles cut in shape of a prism. So let's start. So first, push the 2 thermocol circles inside the prism, not at the ends. Then stick it from the bottom inside the kaleidoscope. Then keep this aside and take the beads and just push it in the hollow tube and just take the hollow tube here at the end. And at last, just take the thermocol circle at the hole. As you can see in the hole, this is reflecting. Thank you. So from the above video, we have observed that when we investigate the kaleidoscope and start twisting it, we see that it is forming some designs at the end. Due to gravity, the beads rest at the bottom of the box, as you can look at the top of it. As we twist, they go in a circular manner, but the mirrors reflect with the beads and keep on reflecting with the reflection. That's how we can see the patterns infinite times. So, from the above experiment and observations, we conclude that the mirrors are the most important parts for making a kaleidoscope. When the light falls on the beads, the one mirror reflects to another and the another reflects it to other one, and so on, as you can see in the picture. That's how we can see the patterns many times. Extension or other different designs. Instead of beads reflecting, we can also take another small materials such as thermocol balls, mirror pieces, etc. You can also color small piece of papers and make them designs on your own, as you can see in the picture.
The topic of the project is Earth as a magnet. The aim is to understand the working of the compass, Earth's magnetic field, the magnetic and geographic poles of the Earth. The materials used are Earth's image, magnet bar, compass, and a stand to suspend the magnet. process. The Earth's image is placed on the surface. A magnet is hung on a wooden stand with a thread allowing it to move freely. The hanged magnet is pinned and allowed to settle. A compass is kept on the side to check the direction of the hanging magnet. This process is repeated to check if the magnet stops every time at the same position. Observation: when the spinned bar magnet stops, its red side, which is its north pole, points at the same direction every time. The compass needle also stops at the same direction, that is of the hanged bar magnet. Findings: the hanging bar magnet is settled in the north-south direction with its north pole pointing towards Earth's geographic north pole. Every time after spinning, the bar magnet rests at the same position. All the magnets have two poles, a north pole and a south pole. The north pole of one magnet gets attracted to the south pole of another magnet. As Earth itself is a magnet, the bar magnet's north pole gets attracted towards Earth's south magnetic pole, that is, the Earth's north geographical pole. The Earth's south magnetic pole is situated at north geographical pole of the Earth and vice versa. The compass also works with the same mechanism. Conclusion: the Earth behaves like a huge magnet. Its south magnetic pole is near its north geographic pole and its north magnetic pole is near its south geographic pole. With the mechanism of two magnetic poles getting attracted towards the opposite poles of each other, the compass needle shows north-south direction and is used for navigation. Limitations: the bar magnet should be freely suspended to work opposite to Earth's magnetic poles. Any other magnet coming in close contact with the compass or the bar magnet will disturb the working of the magnetic poles getting attracted with the Earth's magnetic poles. Citations: Connection Book 6 Standard, YouTube and
Aim to show that the sound waves are created when sound make vibrations in the air. Materials required for the experiment: 2 paper cups, 1 cotton twine, scissors and a marker. Process: using marker, mark holes at the bottom of the paper cups. Second, use the scissors to poke a little hole on the marked part of the cup. String a piece of twine between the cups. Use a long piece of string to help the sound travel farther. Tie a knot at the end of the string to keep it in the cup. One person can hold the phone up to their ear and the other person can talk into the other cup. Keep the string tight for the sound waves to travel correctly.
Me and my sister are going to demonstrate the telephone string. Hello, hello. As you can see, the sound is traveling through vibrations.
Observations: our voice vibrates the air inside the cup, which are then transferred to the bottom of the cup, which is then passed to the string and then to the other cup. We can hear surprisingly far using a string telephone. You can see me holding the string telephone. Findings: the string has to be kept tight for the sound waves to travel. If the string is loose, the sound is less. This is because the loose string causes the vibration to travel all around rather than directly down the string. Conclusion: sound waves are created when sounds make vibration in the air. Old landline phones were created using the same principle as a string telephone. The sound waves are turned into an electrical signal that can travel much farther than a simple string. Limitations. The string telephone will not work unless the string is pulled tightly. Other variables that may keep the sound from traveling well are pinching the string, longer string lengths, cupping hands over the speaker's cup, and using certain types of strings and cups. Extension of the experiment. We could make use of 2 empty tin cans, a nail, a hammer, a duct tape, and a long piece of cotton string or a
Hello, my name is Shambhavi from class 7th A, and today I made a working hydraulic model which lifts heavy objects by a liquid.
This project is based on famous law known as Pascal's law. Pascal's law can be stated that when we apply pressure on the fluid inside a closed container, this force is transmitted to liquid and wall of container.
Prajwalan Singhania. My aim for this experiment is to make a balloon-powered car. By this, I will be using the air filled inside the balloon to make the car move. It's going to be interesting. Material required are balloons, cardboard, 4 wheels, pen ink refills, tape, some decorative material, scissors, pencil, wire tie, and 3 straws. Take the straw, refills, wheels, cardboard, and tape. Cut the straw and put the ink refill in the straw such that little from both the sides should be outside. Fix the wheels and tape it to the cardboard and then flip it over. Step 2. Now you shall take one more straw, put the balloon and tie it with the wire tie. Then tape it properly such that the straw doesn't move. Decoration time. I have used mosaics. You can use anything else to decorate it. How to use? Blow air through the straw so that the balloon is partly filled. Then just leave it on the ground and give it a little push. It will start moving. Here's how we do it. I observed that we must have a lightweight body and light wheels too, so that the balloon's air can push it forward. I also observed that because of the air pressure created in the balloon, it makes the balloon push forward and the air push at the back of the balloon, and thus making the car move. My findings were that the potential energy in the balloon is converted into kinetic energy or energy of motion. As the air is pushed backwards rapidly, there is a reaction that pushes the balloon forward. This comes from Newton's third law of motion, stating that every action there is an equal and opposite reaction. It was an interesting activity and a learning experiment. I am extremely fascinated with cars, but never knew that a simple thing like a balloon can power a car. Overall, it was fun and I was happy.
Physics dispels the darkness of ignorance and helps us embrace the light of knowledge, truth, scientific values, and aesthetics. Its understanding makes us independent, logical, and a better human to live a fruitful life.